Now we'll take a look again at a set of equations, and in this case we keep the slope constant and vary the y-intercept. Remember, the slope is our m value here, and the y-intercept is our b value here. So take a moment, think about what these lines would look like if you graph them all on the same graph. And hopefully you visualize something like this, right? With the same slope, you expect to see parallel lines. So we can't use slope to determine which lines are associated with which equations, but we can use the y-intercept to help us distinguish them. And so that's what we'll do. Before we jump into the problem here, take a look at the axes. Note that each dash represents a half mark instead of a unit mark, right? One step doesn't count for one, it counts for half a unit, whatever the units are here. That's true for the x-axis, and that's also true for the y-axis. They don't have to be the same. We can change the graph and view it in different ways, but that's the first thing you need to do, is to kind of, in your mind, figure out what each dash represents. We can see that they're half steps because from 0 to 2, you have 3 dash marks. So it goes from 0 to half to 1 to 1.5 to 2. Right? It's important to check that, because if you get in a pattern like we did in the last few videos of each step being associated with 1, it's very, very easy to make a mistake and look at a graph and associate with a wrong y-intercept or the wrong slope value. Okay, so the first thing I would do if I have a set of parallel lines like we do here is to see if I have a line that intersects the origin, the 0, 0 point, right? Because I know at that point, if I have a line that intersects it, then the y-intercept is equal to 0. And I see this blue line, line D, is associated with that. And so if I have an equation without a y-intercept, which I do here, equation 4, that's connected. So equation 4 is related to line D, right? And so then now we can just look at the y-intercepts of all of these and connect them to the b value that we see in these equations. So line F right here, we see a y-intercept of -4. So that will be associated with equation 2. Line E has a y-intercept of -2, so that's related to equation 1. Line C has a positive y-intercept somewhere between 0 and 2, and so if we see count 1/2 and then 1, so it'll be +1, so that will be associated with equation 3. Line B is between 2 and 4. It's right in the middle, so that's 2, 2.5, 3. So y-intercept is 3. So it's related to equation 6. And finally, line A, we actually don't see where it intersects, right? It's kind of beyond this the image I chose here, but I know it's larger than +4. So the only y-intercept that's larger than +4, and the remaining one here is equation 5. So that's line A. So hopefully you're able to see that, right? So when we have constant slopes, we have constant y-intercepts in the previous example, or are varying, we can, even without counting the slope values, very quickly identify which equation and which lines are related to each other. This is a very useful tool, right? A lot of your, if you're learning this for the first time, you might see something like this on a test. So drilling these things will be useful. The next set of practice problems will kind of go a step beyond, and we won't write the linear equation in this form, and we'll see if we can associate the lines and graphs and still match them even if they're not in that the specific y = mx + b form.